All right, while you are pulling this up, I want you, with the person sitting next to you, to think about these two tables here. They are very similar. The one on the left, you can do it without using the chain rule, and the one on the right, you must use the chain rule to take the derivative of it. Okay, so kind of compare the two. Maybe why do we need to use the chain rule? I kind of explained it a little bit already up on the board, but talk with your neighbor about why you think you might need to use the chain rule. What's the difference in those problems? Why are these things different here?
It's difficult.
Because it's difficult. Because you don't know how to do it. Well, if you think about this on the right, x squared plus 1 is just underneath the square root, right? So I've got the square root function here, as well as the stuff underneath. So really, there's not just one function here. There's two things that's going on, right? I have that x squared plus 1, and then I'm taking the whole square root of that function, right? If you had just like the square root of x, could you take the derivative of that? Yes, but I've got more than just x underneath there now. I've got x squared plus 1. There's something else nested inside of it, okay? So when we're thinking about the chain rule and when we use the chain rule, think about who likes M&Ms? Skittles? Blow Pops? A little bubble gum on the inside, okay? Think about something like that. Think about something like that. Has a hard candy on the outside and then something else on the inside, right? M&M's has like a million different flavors now. What's the best one? Peanut butter? I would actually agree. Or caramel. Caramel's pretty good. Okay, but the inside, right, is that caramel or that peanut butter or the peanuts, right? And then on the outside is that hard kind of sugar coating, right? So there's two pieces to that kind of idea. So that's this video here. You can click that and watch on YouTube if you want at a later point. But we are going to go down here to this picture right here to talk about, if we think about our blow pop here, okay? The inner function is that bubble gum on the inside, okay? The outer function is that candy shell. So we need to first, to get to the bubble gum, eat the outer shell, right? We're not like hacking it in half and then like getting the bubble gum right away. Okay, we have to eat the outside before we get into the inside. So basically what the chain rule says is we have to take the derivative of the outside function. So the derivative of this f of u, okay? And then we can take the derivative of the inside, okay? So I've got two functions we're taking the derivative of, okay? Basically, in complicated math lingo, that's what this says right here, okay? This chain rule says that if we have a function, f of u is differentiable, if u and g of x is a differentiable function, then our composition of functions is also a differentiable function, and this dy dx could be split up into dy du, so we've got one derivative times the second derivative, or the outer times the inner, right? Same thing over here, and a little bit more of a better notation. This is saying f prime of g of x, so that's saying the derivative of the outside piece. I'm going to write that down here. Derivative of outside and this g prime of x is the derivative of the inside function. So we're taking the derivative of the outside, multiplying by the derivative of the inside. All right, so we've kind of got a chart here to break it down. This is not necessarily how you're probably going to do it even on your homework, but I just want to show you how you can break this down if this idea is kind of confusing to you, okay? So if we can rewrite it so that we don't have quotient rule, let's do that. Could I rewrite 1 over x plus 1 to not be a fraction? Yeah, I could rewrite this as x plus 1 to the negative 1 power, right? Okay, our bubblegum, our inside function is this piece right here, okay? So we're going to say that u equals x plus 1. Okay, y equals f of u, that's our candy outside piece. So that's going to be this parentheses here to the negative 1 power. So we're going to say that y equals u to the negative 1 power. Okay, do we see how we have two functions going on? We have something with an exponent, and we just have a linear factor right there, x plus 1. Okay? So then, there's not a third column, but we're going to make a third column here. I'm just going to split this last column in half. Okay? Because on the right-hand side, I want to actually find the derivative of this function. Okay? So when I find the derivative, I am taking first the derivative of the outside function. Okay, so what is the derivative of just u to the negative first power? Negative 1 u to the negative second power. Okay, that's the derivative of the outside piece. Then we need to multiply that with the derivative of the inside piece. What's the derivative of our bubblegum function on the inside?
1.
Just 1. Okay, now however, we said that u is equal to what? X plus 1, right? So really my final answer here would be I have negative 1 times x plus 1 raised to the negative second power times 1. Now, do you need that times 1 at the end? No, not necessarily. Okay, but I'm just showing you where everything came from. So remember, your original function that you were given was y equals x plus 1 to the negative first power. Okay, so we let this inside piece just be u so that there is less going on, but really you are more than welcome to jump from your original function over here to this final answer, okay, once you get some practice here, because if we look here, this negative 1 is just going down in front, right, and then I'm subtracting 1 from it up top, and then all you're doing is you're taking the derivative of the inside and you're multiplying that. Okay, does that make sense? All right. Okay, I hear some of us say I don't get it. Let's go ahead and talk about it. If you are still working, you are more than welcome to, but make sure that you are getting the same answer I am. So if I look at sine of 2x, what do you think your inside function is going to be? 2x. So let's go ahead and say that u equals 2x. Okay? Then my outer function is going to be what? Sine of u. Okay? So now I start out by saying, okay, what is the derivative of the outer function? Well, the derivative of sine of u is cosine of u. And then the derivative of 2x would be 2. Okay? Now I just got to plug back in what my u is, right? My u is cosine 2x times 2. Now, does that simplify to give me cosine of 4x? No. Okay, it's saying we're taking cosine of 2x timesing that whole quantity by 2, right? So on your homework tonight, you are going to have some kind of, there's going to be quite a few trig functions, so I apologize if you don't like it. Hopefully you get a little bit better at it for this homework. You are going to have to sometimes rewrite things, so maybe your answer looks like this on your circuit worksheet, whereas when you did the derivative, you just had cosine of 2x times 2. Okay, so it might be in a different order, or things might have been simplified to give you your final answer there, okay? All right, letter C here. Could I rewrite this so that I don't have a square root? Yeah, I could rewrite this as 3x squared minus x plus 1 to the 1/2 power. Okay, when it's written like this with a power, it's pretty easy to see. What is my bubblegum? What is my inside function? The 3x squared piece, right? This piece right here, okay? My outer function is that whole thing that's raised to the 1/2 power, okay? So we know that u is going to equal 3x squared minus x plus 1. And my y is going to equal u to the 1/2. Okay, so if we take the derivative, what is the derivative of u to the 1/2? 1/2 u, right? To the negative 1/2. And then we're timesing that by the derivative of our bubblegum. What's the derivative of 3x squared minus x plus 1?
6x minus 1?
6x, yes, minus 1. Now, we got to be careful when we write it like this, because this looks like I'm just multiplying by 6x, and then I'm subtracting 1 from that whole quantity. So I got to have parentheses around this whole thing, okay? And then for your final answer, you're going to plug back in what u was. So I'll have 1/2 times, we had 3x squared plus, oops, it was minus x plus 1 times 6x minus 1. Oh, I forgot the fraction exponent. Yeah, this should be negative 1/2 there, right? And then, yes, if this was a multiple choice question or something like that, and maybe this answer wasn't on there, but if you simplified, the answer might be on there. That's when you'll have to do that. If you're just taking the derivative of something on a quiz or a test and you don't have to do anything else with it, just like on that quiz that you just took, that is fine. You can leave it like this. Okay, but yes, the negative 1/2 you could put on the bottom and take the square root of that thing instead. Okay. All right, last one here. Tangent squared of x. If I have tangent squared of x, that is the same thing as tangent of x squared, right? Okay, so what is my bubblegum function here? Tangent of x, right? The whole thing, tangent of x. Oh, no. Anyways, okay, so my inside function is what? Tangent of x, right? This piece right there, tangent of x. Okay, so u equals tangent of x, and my outer function is just u squared. Okay, so what is the derivative of u squared? 2u. And then we got to multiply that with the derivative of our first inside function, which is tangent. So what's the derivative of tangent of x? Secant squared of x. And then we just got to replace the u with our function. So 2 times tangent squared of x, or sorry, tangent of x, my bad, times secant squared of x. Does that kind of make sense? Cool. All right, go ahead and do this example right below it, example 2, and then check your answer with your neighbor, and I'll put the answer up here in a second. All right, did you guys get 3 times x squared plus 1 squared all times 2x? Yes? Okay, good. Very good. All right, so a little bit more of a generic rule here. Again, it's just another sort of notation. This, all it says is basically if we have something to a power of n, I'm going to move that n down in front, and then I'm going to subtract 1 from it. U could be any sort of function. It could just be x, or it could be like, x squared plus 5, right? And then you're just going to take that derivative of that base of u, okay? So A is basically what we just did, so I'm going to let you guys try out letter A and B and C. But for B and C, you are going to need to rewrite it so that it has one exponent on top, okay, when you are solving. So try A, B, and C out, check it with your neighbor, and then we'll go over it here in a little bit. If I am taking the derivative here, this 3 is going to move down in front. I'm going to leave that 3x minus 2x squared, and then what do I do with 3? Subtract 1, right? And then I multiply by the derivative of the inside. So the derivative of the inside here would be, negative 4x plus 3, or 3 plus 4x, right? Order there does not matter. And then you are done, okay? Do we all get that for letter A?
What? Isn't it 3 minus 4?
Oh, sorry. Yes, 3 minus 4x. There you go. Now are we good? Okay. All right, letter B. How did you guys rewrite letter B?
Y equals x squared minus 1 minus 2
Yes, to the 2/3 power. Okay. Now that I only have one exponent, we can use our power rule in the chain rule, right? So this becomes 2/3 down in front times x squared minus 1 to the what power? Negative 1/3. And then I'm going to times that by the inside function. So times this by the derivative, which is 2x, right? Now again, on your circuit, you might have to do, maybe this is in the denominator, right? But this is all you need to do if you're just finding the derivative using the chain rule, okay? And then letter C here. How would I rewrite letter C?
times 2x minus 3 is negative 2.
Yeah, I would just make this to the negative second power, right? So this would be 2x minus 3 to the negative second power. Could I just do the quotient rule here? Yeah, we could do the quotient rule. I think this is going to be quicker so that we don't have as many things, right? Low D high minus high D low over low squared. That's a lot of stuff that we have to simplify out. So if we just take the derivative here, take that negative 2 down in front, I'll have 14 times 2x minus 3, and then that will all be raised to the what power? Negative third. And then, yeah. And then I take the derivative of the inside. What's the derivative of 2x minus 3? 2. Okay. Oh, there we go. All right, we're moving on to some trig functions. And we're not going to freak out just because there's trig functions going on, yeah? Okay. Again, here are your 6 trig functions that we should have had memorized for our quiz and will continue to have memorized for the rest of this year, no matter when I ask you what the derivative of these things are, yeah? Okay, so it's written a little bit differently though, okay? It's basically saying if you take the derivative of sine where u is anything, it could be x squared plus 5, it could be x, it could be 2, whatever it is, you're taking the derivative of sine, which is cosine, and then you're also taking the derivative of the inside, okay? So it's again just another way of writing your chain rule, just in a different notation, okay? So let's look at example A here. Example A, I've got sine of 2x. So I just need to take the derivative of sine, which is cosine. So I have cosine of 2x. And then I just need to multiply by the derivative of the inside piece. So derivative of 2x would just be 2. Okay, letter B, I've got cosine. Okay, so I need to take first the derivative of cosine, which is negative sine and then I'm going to leave it as 3x minus 1 times 3. And the last one there, we've got y equals secant of 4x. So take the derivative of secant, we get secant tangent, right? So secant of 4x times tangent of 4x times the derivative, which would be 4. Again, you do not multiply the 4 with the 4x to simplify it to 16x. It would stay times 4, okay? Feeling okay so far? Okay. All right, our last examples are going to use the chain rule, but it's going to use it more than one time, okay? So instead of just taking the derivative of the outside and the inside, now there's 3 layers to this thing, okay? For example, if we look at letter A, I've got sine of 3x raised to the 4th power. This is the exact same thing as saying sine of 3x all to the 4th power, okay? You guys agree? That looks kind of like a 9, but let's make it a 4, okay? So we're going to start with the outermost function. The outermost function here is the fact that we're taking this to the 4th power, okay? So the derivative is going to be 4 times sine of 3x, but, oh, to the 3rd power, sorry, forgot that. Then I need to take the derivative of the inside piece. What is the derivative of sine of 3x? Cosine of 3x, right? But then we also have to take the derivative of that inside piece here of 3x, which gives me 3, right? So times 3. Okay, you see how there's 3 pieces there? I'm going to change that to black there. It's a little hard to see that yellow, okay? So we can leave it like that. No need to simplify unless you're solving it for maybe figuring out what the answer is on your circuit or simplifying for a multiple choice question, okay? All right, let's look at letter B. Letter B, I've got y equals the square root of secant of x divided by 2. So I need to rewrite this so that way we can use my chain rule. So what can I rewrite this to be? To the 1/2 power, okay? So go ahead and try out taking the derivative of this function. I'll kind of zoom out so you can see that other example as well. Take the derivative of the outside function, then go to the inside, and then the innermost function. So there should be 3 things multiplied together. Looking like a lot of us got it.